Hello everyone, my name is Ashok. I am working as a physics teacher and physics lecturer and physics professor from last 7 years. So today I am going to discuss one of the very important topic in a second year, that is the ray optics. So under that I will be discussing one very important and it is very crucial for competitive level. So that is light refraction. So let's try to understand what is this light refraction. So here I will be starting with the definition of refraction of light. When I say refraction of light, in general we understand that it is a refraction, nothing but a bending. So here light, the term is that. So I can define this light refraction as the bending of light when it is traveling from one medium to another medium. So medium should be optically transparent. So that should be the condition. So here our question is, why light bends when it is traveling from one medium to another medium? So we have to know the reason. So here I can give the one simple reason, that is due to change in speed of light. So if we see the basic properties of a light, where we have learned the property, that is very first property is the rectilinear propagation of light. So that means light is always travels in a straight path, and when we look at the speed of light, that is 3 lakhs kilometer per second. If we write in terms of SI unit, that will be 3 into 10 power 8 meter per second. So here C indicates a speed of light in air or vacuum. So just imagine how fast this light can travel in air medium as well as vacuum. What about in different medium like optically transparent medium like water as well as a glass medium? So where the light speed reduces. So let's see by simulation. Before that, let's try to understand very important note, that is the refraction of light is essentially it is a surface phenomena. Okay, so we will get to know why do we call it as a essentially surface phenomena in a simulations. Okay, so now here the cause of refraction or change in direction is because of change in speed. So you'll understand better if I show you the simulations. So here if I consider state of matter, okay, state of matter. So where substance exists in a 3 states. One is solid, second one is liquid, and third one is a gaseous state. So when we look at the molecular model of all these state of matter, first one you can look at this, only this part where molecules are closely packed. You can see the intermolecular space is very less, and when you look at the liquid state, you can observe the spacing little more compared to the previous case, that is a solid. And let's look at the last state, that is a gaseous state. Here you can see the intermolecular space is very large. So if I consider this solid and liquid and gas as a 3 roads, one it is completely filled with the vehicles, and second one it is partially filled, and last one it is a less, means traffic is very less. If I want to travel from one place to another place using these 3 roads, so in which road do you think I can reach faster? Absolutely, we know that the last case where there is traffic is too less. So hence here myself I will be considering as a light, so that I can travel faster in last case, that is a gaseous state. So here transparent medium for the gaseous state I can consider air medium. So in the same way for liquid as water and glass, it is for solid. Okay, so due to this intermolecular spacing, the speed of light varies when it is transferred from one optical medium to another optical medium. So let's try to understand bending of light. So here I will be considering a light of a single color, that is a monochromatic light. So here I am having 2 mediums. The first one is air medium, second medium is a denser medium. So that is a glass medium. So here I'll call air medium as a rarer medium and glass as a denser medium. So in the word itself indicating air as a rarer medium, glass as a denser medium. So denser means the molecular space is very much. and compared to this air medium. Okay, so now if I see here optically denser medium and optically rarer medium, we need to understand first what does it mean. So here if I talk about optically denser medium where the speed of light reduces due to intermolecular space. If I talk about optically rarer medium where the speed of light increases. Okay, so if I consider one case where all these are considered molecules. Okay, if the light is traveling from this medium and this medium, it is the molecules are very closely packed. So what happens? Definitely the speed of light decreases. Okay, in the second one, here it is a denser medium and the light is traveling to the rarer medium where the intermolecular space is very less. So hence the speed of light increases. So C nothing but speed of light. In sometimes in a medium apart from air as well as vacuum, instead of C we will be using a V. This is also indicates speed of light in a different medium like water as well as glass. Okay, so here it is traveling from rarer to denser medium, the speed is reduced. Here the light is traveling from denser medium to rarer medium, hence the speed of light increased. Now here I will be using monochromatic light. So let's see what happens. So these are the two surfaces. Okay, these are the two mediums which is separated by one surface that we call it as an interface. Okay, so let's see. Ignore about this part. This is the reflection part. Okay, light reflection. Here there is a bending of light ray. Just imagine if there is no medium, the light would have traveled in a straight path, but it is not happening. Why? Because here we have a two different medium, that is difference in densities. Okay, so now here there is a bending of light due to change in speed of light. According to previous understanding, the speed of light in a air medium comparatively, this is air medium, this is a glass medium. Definitely air medium is rarer medium and glass medium is denser medium. So according to the idea we have studied previously, your speed of light 1c means 1 time of a c. C is nothing but 3 into 10 power 8 meter per second. So the same light traveling in a denser medium, let's see what happens to the speed of light. So here speed of light is 0.67 c, means the speed of light is reduced. Okay, now speed of light is 0.67 c. Absolutely the speed is reduced. Here 1, here but here 0.67 c. C nothing but 3 into 10 power 8 meter per second. Keep that in mind. Okay, now what happens if I consider first one as a denser medium and second one as a rarer medium. So what is the thing? What happens to the speed of light? So the light is traveling in a denser medium to rarer medium. So here it is a denser medium, definitely the speed should be less. Here rarer medium, the speed of light should increase. So let's say using speedometer, here the speed of light is 0.67 c. If I consider the speed of light in rarer medium, speed of light is 1 c, that is a 3 into 10 power 8 meter per second. So that indicates due to change in speed makes a refraction of light. The reason behind the refraction of light is just a speed of light changes. Okay, so let's move on to the next concept, that is laws of refraction. That laws of refraction is also called a Snell's law. So this Snell's law have two very important points, that is if I consider first one as the incident ray, normal and refracted ray lies on the same plane. Let's try to understand diagrammatically. If I consider this is a surface which is separating two medium, and here I'll be considering it as a incident ray. Okay, this we call it as a incident ray I, and this point we call it as a point of incident with separating two medium, and here there is a one normal normal nothing but a perpendicular drawn to the surface with separating two medium, and the angle between this normal as well as incident ray, we call it as a angle of incidence. Angle of incidence. Okay, and this dotted line indicates a normal. Okay, so if there is no medium, the light would have traveled in a straight path, right? The light would have traveled in a straight path. But what is happening? The light bends. Simulations we have seen. But here we need to understand how light bends. So here for the reference point, I'll be considering this as a rarer medium and this as a denser medium. Above one rarer medium and below one as a denser medium. We know that in denser medium the light speed decreases, hence it bends towards the normal. Towards the normal. If I consider this as a refracted ray, this as a refracted ray. Okay, so this one we consider it as a refracted ray, and angle between normal and refracted ray we call it as a angle of refraction. So here you need to concentrate on 3 points. This incident ray, normal and refracted ray lies on the same plane. What does it mean? Same plane means what? For example, if you see all my fingers, okay, if this side, if you look at all these fingers lies on the different planes. If I see from this side, you are able to see only one finger. That means all these fingers lies on the same plane, like a hands of a clock. Is it clear? So that is the meaning. So here the incident ray, the refracted ray and normal at the point of incidence. So here this point is very, very important. All lies in the same plane. The second one, the ratio of sine of angle of incidence to the sine of angle of refraction remains constant. What does it mean? Mathematically, if I express it, sine I divided by sine R, that is constant. What is that constant? So let's try to understand. Here you see, here the normal, this dotted line is a normal. Okay, just I'll reflected ray. Okay, ignore this reflected ray. Here the angle between normal as well as incident ray is 32.5 degree. And here the angle between refracted ray and normal is 53.7 degree. Okay, so if I take the ratio of sine of 32.5 degree and sine of 53.7 degree, I'll be getting one value. So for example, if I consider it is a 1.33. Okay, okay, here I'll be considering air medium. This is a glass medium. So if I consider sine I is 32.5 degree, sine R it is 21 degree. So ratio of these two I'll be getting as a 1.5. So that 1.5 will remain same for any angle. Any angle. See, as sine of angle of incidence increases, the sine of angle of refraction is also increases. Angle of refraction increases as angle of incident increases. Okay, so if you take ratio of the sine of angle of incident and sine of angle of refraction gives the same value, that value we call it as a constant. That constant we call it as a refractive index of the medium. Okay, so let's try to understand what is that refractive index of the medium. So here refractive index of the medium, so this one we call it as a refractive index of the medium mu. Okay, so in bracket I'll be writing Ri, refractive index. Let's try to understand what is this refractive index. By seeing the formula you can define it. How? The refractive index of the medium, that is the second medium, is defined as it is the ratio of sine of angle of incidence to the sine of angle of refraction is called refractive index of a second medium. Okay, so that is the definition. Now here you can see refractive index. The refractive index of a second medium with respect to first medium is defined as the ratio of sine of angle of incidence in the first medium to the sine of angle of refraction in the second medium. So in the refractive index we have two types. One is absolute refractive index, second one relative refractive index. Let's try to understand what is the difference between these two refractive index. So here absolute refractive index. So generally if I express it, mu c divided by v. What does it mean? The speed of light in a air or vacuum to the speed of light in a given medium. So here if I consider, here first medium I have considered air, second medium I have considered glass, or else I can consider water also. So this ratio in the rarer medium, air or vacuum should be there. That is speed of light, that is 3 into 10 power 8 meter per second. But in the second medium, that is, it can be water or it can be glass or any other transparent medium other than air. Okay, so this refractive index we call it as a absolute refractive index. Then what about the relative refractive index? If I consider instead of air, if I consider a glass, here glass, ratio of a glass and water. If I consider here water and here glass, this ratio is also called refractive index, that is a relative refractive index, where you are not able to see air or vacuum medium. So that ratio we call it as a relative refractive index. Then how to define it? So here same way, refractive index V1 divided by V2. Are you able to see any C? No. C is nothing but speed of light, that is 3 into 10 power 8 meter per second. Okay, so this difference we call it as this one as a absolute refractive index. It is the speed of light in air to the speed of light in a medium. Here both are in mediums only. Yes, of course air is also medium, but here we are considering particularly the air medium or vacuum medium. Is it clear? This is other than air. If we consider water as well as glass or water, any transparent medium other than what air, then we call it as a relative refractive index. Okay, so let's move on to some refractive index of a medium. For example, if I consider refractive index of air, the refractive index of air is 1, refractive index of water is 4 by 3, it can be written as 1.34, and refractive index of glass, that is 3 by 2, 1.5. These are the definite values. And here I need to tell you one very important point is the refractive index cannot be less than 1, because air itself has a refractive index 1. So that is purely transparent medium. So even though it is having 1, so refractive index of any medium will be greater than 1, cannot be less than 1. Got it? So let's move on to the next one. So then when the light is traveling from one medium to another medium, that is a transparent medium, the light should bend, right? So is there any condition where refraction is happening but there is no bending of light? Okay, so here we have a two condition. One is the condition for light ray pass undeviated on refraction. Refraction is happening but there is no bending of light. So generally refraction nothing but it is a change in speed of light. So let's say what is the first condition? When the angle of incidence at the boundary of two medium is 0. So that means angle of incidence is 0. So according to Snell's law, if angle of incidence is 0, angle of refraction is also 0. So what does it mean? If I consider a surface, okay, if light is falling in this way, okay, what is the angle? Here you can see here 90 degree, but what is the normal? What is the angle between normal? So normal line as well as incident ray on the same line. So that means here angle of incidence 0, and don't consider this angle between surface as well as incident ray. We are not talking about it. Angle of incidence means it is the angle between normal as well as incident ray. Okay, so here what happens is refracted ray travels in a straight path. So here there is no bending of light. So this is the first case. So by simulation, if you see angle of incidence is 0 over here. Angle of incidence is 0. And what about angle of refraction? But angle of refraction is also 0. But when you see a speed of light, 0.75 in the second medium, 0.67. So speed is reduced. Okay, change in speed. Okay, now second one is when the refractive index of two medium is same as refractive index of medium 1. So here the condition is if refractive index of a first medium is equal to refractive index of a second medium. In such situation there will be no bending of light ray. For example, here two mediums we have, right? Two different mediums. What happens if I consider both the side, above the surface as well as below the surface, if I consider same medium, that is refractive index same. So here water is there. Let's consider water itself. See, initial case there was a bending of light. Once you observe bending of light, if I consider same medium, what happens? Yes, here the light is traveling in a straight path. Still there is a change. There is no change in path of light. Okay, here speed also will remain same. See, 0.75. Here 0.75. So refractive index is same. When refractive index is same, then refraction, that is bending of light, will not take place. Is it clear? So let's move on to the next one. Refraction of light through the glass slab. So let's try to understand what happens if I consider not only one surface, two surface, that is a glass block. If I consider a glass block, okay, if I consider a glass block, let's see what happens. So here I'll be considering a glass block A, B, C and D. Okay, so let's try to understand. First I'll be considering incident ray. Let me consider incident ray. Okay, what if there is no medium at all? So light would have traveled in a straight path. Am I right? Light would have traveled in a straight path, but it is not happening because due to a first surface, that is AB. Here let me draw one normal with a dotted line. So this is the first normal. So due to a change in medium, so light gets refracts. So here I'll be using white color for refracted ray. It bends towards the normal. Okay, so here it is a incident ray and this is a normal one. Okay, two surfaces are there, hence I'm considering two normals. Okay, now so here it is a refracted ray. Now if there is no medium at all, okay, if second medium is not there, that is a DC, if the surface is not there, light would have traveled in a straight path, right? But it is not happening. Why? Again I'll be considering normal over here. It is traveling from denser medium to rarer medium, hence the light will bend away from the normal. How it travels? Let's see. Bend away from normal like this. Okay, like this it will be moving. So this one we call it as a emergent ray. So here angle between normal and incident ray we call it as a angle of incident. Angle between normal and refracted ray we call it as an angle of refraction, and here angle of emergent. So this angle and this angle will remain same, and very important factor is here this fellow, that is a perpendicular distance between emergent ray and path of incident ray. So here consider x and y. So this x and y we call it as a lateral shift. Okay, lateral shift. So this, the perpendicular distance between the original path of light and the emergent ray, we call it as a lateral shift. There are two types of shift. One is lateral shift, another one is vertical shift. So there are a lot of competitive questions appears based on Snell's law, okay, where this Snell's law used to find out critical angle and total internal reflection, and this lateral shift as well as vertical shift, as well as bird wave, as well as image from the eyes of a fish. So to solve all these competitive level examination questions, first you need to understand the basic concept of all these refraction of light. Okay, so in the future in the next class we are going to discuss about formation of image due to a lens using refraction concept. Until, take care, bye bye.